What does emission intensity depend on? First, we must understand what emission intensity is. Defined as the number of photons being emitted at a specific wavelength, emission intensity can be observed by peaks on an emission spectroscopy graph. Visibly, the visible light that is given off and observed by the human eye is brighter at higher intensities and is modeled by higher peaks on the graph.
To understand what determines emission intensity, it must be first understood why there are variances in emission intensity amongst different substances. As seen in lab, the same amount of dye and activator was added to the glow sticks, but there were variances between emission intensities. This means that the activator cannot be a determinant of emission intensity, as this would make the intensities the same amongst the substances. Therefore, intensity must be determined by the substance itself. This means variances in intensity must be related to a substance's capacity to absorb energy. Dyes are receiving the same amount of energy but emitting different amounts of photons. This arises from a difference in the amount of energy that substance can absorb. As a substance can absorb a significant amount of energy, will emit more photons than a substance that cannot absorb as much energy. When a substance takes in a large amount of energy, its electrons will raise to a higher energy level than the substance that cannot take in as much. The substance that rose to a higher energy level is less favorable than the substance that rose to a lower energy level and will release energy faster due to its higher unfavorability. This allows for more photons to be released at a faster rate.
This means emission intensity is dependent on the dye and not energy input. The dye determines the absorbance capacity based on its molecular structure and composition, and therefore will also determine the speed at which electrons are raised to a higher energy level. The structure will be the determinant of how likely an electron will be excited to a higher energy level. There are many different aspects of structure that contribute to how much energy a substance can take in, including geometry, composition, occupied energy levels, etc. For example, a substance with less energy levels like fluorine will only be able to hold a certain amount of energy as it can only raise its electrons to 2 energy levels, rather than a substance with more energy levels like bromine, which has 4 energy levels that an electron can be excited to, and therefore will have more ability to hold energy and thereby can have a higher frequency of absorbance and emission.
Emission intensity can be compared to the varying metabolisms of different people. If someone were to intake a large amount of food with the calories that are being input into the body being converted into muscle mass, the metabolism of the individual's body will determine how the calories are metabolized. For someone with a high metabolism, the calories will burn faster in the body as the energy from the food will be used more quickly and will result in the person having a smaller body. If the same amount of food is given to a person with a lower metabolism, the calories are burned slower in the body, but less energy is metabolized, resulting in that person having a larger body mass. The photons that are emitted from the electron relaxing into its ground state are released like the energy humans burn after they have converted their food into energy. The emission intensity is comparable to the process of metabolizing food because the release of energy is reliant on how the composition absorbs energy, not the energy that is put into the system.